Hey everyone, welcome to another session of CeerazzleDazzle Physics. In today's session, we're going to be talking about orbital motion. Okay, so the first thing to consider is, what exactly is an orbit? An orbit simply means a path in which one object goes round another. So it's a path in which one object goes round another. So, classic example, we've got the sun over here, and here we have Earth. So, classic example, we've got the sun here, right in the centre, and we've got Earth over here. Right, we can see that blue line represents the orbit, so the Earth is going to orbit the Sun. So the Earth is going to follow this path all the way around. Okay, so the Earth is going to go all the way around. Right, the reason why it's following this path is because there's a force keeping the Earth being attracted towards the Sun. That force is due to gravity. So gravity, let's draw that arrow over here. That force is pulling it inwards over here. This is gravity. Okay? Right, but let's say the Earth moves to this position. Different coloured pen. Right, so now, what happens if the Earth moves to this position or this position? Which way will the force be? Well, the force will be directly towards the Sun. So if you look carefully, we know that gravity is always pulling it inwards. So gravity acts to the centre of the circle. Right, so there's a force which keeps the planets orbiting the Sun. So gravity is pulling it inwards all the time, towards the centre of the circle, and it's always towards the centre of the circle, right? So there's a force always pulling it towards the centre of the circle, so always towards the centre of the circle. And obviously this is orbital motion. Right, let's look at another example and let's try and discuss what's happening. So what about this? Okay, let's start off with the following question. Is an object in a circular orbit accelerating? So is an object in a circular orbit accelerating? Right, so look here. We've got an object going around another one. Round and round and round. So right now you can see that it's going round. So just follow my pen. Right now that is a constant speed. It's going around at a constant rate. So yes, it seems like, it's a constant speed right now. So therefore it's not accelerating. But something is changing for that object. What is it? Right, let's look at the direction in which the object is facing. What's happening to the direction? Well, we can see that the direction, look, it's facing this way at one point, then this way, then this way, then this way. So the direction in which the object is facing is constantly changing. Right, so the first thing we're going to put down is the object is moving at a constant speed. So the object is moving at a constant speed. Okay, so the object is moving at a constant speed. But what is actually changing? The direction of the object is changing. So the direction in which it is facing is changing. So what does that mean? It means that the velocity is changing. The reason why is because the direction is changing. So the velocity is changing because the direction is changing. So the velocity is changing as the direction is changing. But now you've got a change in velocity. Yes, change in velocity with regards to time. What does that indicate? Well, hopefully we can remember that change in velocity with respect to time means it is accelerating. So therefore there will be an acceleration. So as there is a change in velocity, there will now be an acceleration. And you know the reason why is because acceleration is change in velocity over time. Right, so recap. So is an object in a circular orbit accelerating? So right now, if we have an object moving at a constant speed, number one, even if it's moving at a constant speed, the direction is constantly changing. So the direction of the object is constantly changing. If the direction is changing, therefore the velocity is changing. And if there's a change in velocity with respect to time, therefore there will be an acceleration. The reason why, acceleration is equal to change in velocity with respect to time. Easy stuff. Right, what about the following? Okay, so what happens if someone says to you, calculate the velocity of an object in an orbit. Calculate the velocity of an object in orbit. Right, so to work out the velocity of the object, we know that velocity is equal to displacement, over time. So s divided by t. The displacement, if I go around a circle, is going to be the circumference of the circle, so going all the way around. So therefore it will be equal to 2 pi times by r, where r is the radius. Look carefully. It is equal to 2 pi r divided by, and the time taken to make one oscillation is known as the time period, if you've forgotten. So t is equal to the time period, which is the time taken for one oscillation. Right, so we have another formula now. It's going to be v is equal to 2 pi r divided by t. So v is equal to 2 pi r divided by t. Right, easy stuff. Now, recap from the top. Let's go right back to the top. So we said right at the start, orbital motion, things moving in orbits. Right, so we know, let's say for example the Earth is going around the Sun, there is always a force pulling it towards the centre. That force is going to be gravity in this case. But in general, the force pulling it towards the centre of the circle, that is going to be called the centripetal force. I'm going to put that on the side here. So it's called centripetal force. Centripetal force. So if someone asks you what is the force pulling it to the centre of any circle, it's called a centripetal. In this example, gravity is the centripetal force here. Right, so always towards the centre of the circle, that's where the force is. Next of all, it's going to be, is an object in a circular orbit accelerating? Well, we know that the direction is changing, therefore there is a change in velocity, and change in velocity with respect to time, therefore it will be accelerating. So there we go. So an object, although it's moving at a constant speed, it will be accelerating because the velocity is changing. Scrolling down, calculate the velocity of an object in an orbit. We know the velocity is going to be the displacement divided by time. So for one rotation, the displacement is going to be 2 pi r. That's the circumference of the circle. The time is going to be the time period, which is going to be capital T. There we go. So we get velocity is equal to 2 pi r divided by t. And that's it for another session. I shall see you next time for more cool physics. Make sure you like and subscribe to all my videos. Keep me going, guys. Ciao, ciao. Goodbye.